Let me do some brief introductions. So as I said, my name is Gabe Arnold. I'm with the lab here at PNNL. I'm kind of new to the lab. I've been here about a year, but I've worked with the lab for quite a few years before that, and with DOE with various roles working with utility energy efficiency programs. And as I said, I'll be moderating. Mark, you want to say a couple words about yourself and organization and role?
I'm sure. I'd be glad to. My name is Mark Lean, and I manage the industry relations for the Illuminating Engineering Society. And prior to that, I did lighting design and sales for about 2 decades. I ran the educational centers for Cooper and Hubble Lighting, and I was the director of government and industry relations for OSRAM. I'm currently on about 20 committees, including ASHRAE, ISO, the Advanced Energy Design Guides, 189.1 that writes the International Green Construction Code, and others. And along with 2 of my colleagues at IES, we are actively engaged with or monitor over 100 lighting industry-related organizations. And the IES also works very closely with the DOE BTO office. And once again, we'll be co-sponsoring the Lighting R&D workshop scheduled for February 1st through 4th.
Awesome. Thank you, Mark. We're very lucky to have Mark. And so he's going to be doing a guest presentation on GUV lighting. Felipe.
Hi, Gabe. Hi, everyone. Yes, I'm Felipe Leon. I'm with Pacific Northwest National Lab, and I'm the lead for the Integrated Lighting Campaign, which I'll be talking about today. So I'm really excited to share that with everyone that's called in. I also work on some other lighting projects. I've worked a little bit on flicker, as well as some organic light emitting diode projects, and have also worked on energy conservation standards in the past. Thanks, Gabe.
Thanks, Felipe. Michael?
I'm Michael Meyer. I've been with the lab 13.5 years. I work on some regulatory analysis as well as a number of field projects. And I'm also on the 90.1 ASHRAE committee that Mark Lean is a member as well.
Thanks, Michael. All right, I had hoped to kind of go around the room and see who else is on for attendees. I don't think we'll have time for that, but one thing about Zoom is the meeting software reviews here, so you can see who else is on. So I'd encourage you to check that out and see who's attending today. So here's our agenda. We're going to spend a good amount of time hearing from Mark talking about germicidal UV lighting, a pretty hot topic with what's going on out there with the pandemic. Mark's going to present for about 17, 20 minutes, and then we're going to open things up for questions. So I want to encourage you to write down your questions, and you can ask them verbally once he finishes, or you can write them into chat. And following Mark, we'll hear from Felipe and Michael about a couple of new lighting initiatives that the Department of Energy has recently launched. Or, sorry, one of them is launched and the other one's about to launch soon. And we always try at the end of these meetings, this is my first one, but as I've understood, to have some time at the end for open discussion for you to bring up any topics of interest or ideas or thoughts or questions. So we'll try and save some time at the end as well. And so with that, I will go ahead and hand things over to Mark. Let me stop my share.
Gabe, real quick, as you do that transition, could I ask that those that have called in, if they're willing to put their organization also in the chat window so that we can just have that?
Yeah, I think we'll actually have
or
it
so people can know.
Data.
Yep.
Yeah.
Gabe, is that showing all right on your screen?
It is, yep, looks good.
All right. Well, I'd like to thank everyone involved for extending the invitation to me to present this today. In the interest of bandwidth, I'm keeping my video feed off. The topic I was asked to present on today is germicidal ultraviolet disinfection, or GUV. It's one of those subjects that's not exciting, but it's necessary for lighting professionals to have some understanding of. And typically I spend an hour or so on this, but you're the smart class, so we're going to distill this to about 15 minutes. We will not be certifying anyone as an expert, even an internet expert afterward, but you'll receive a basic overview with direction to other immediately available resources for more information. And it's my understanding that everyone on this call will receive the slide deck by email, should you want to use the links or review the content later. I want to give you just a little bit of foundational information on viruses before we move into this, because we're primarily going to be talking about disinfecting airborne viruses. Viruses are one of the smallest microbes on our planet. They're even smaller than bacteria. And they're different than bacteria because they can't survive on their own. They're not actually alive. They need to be inside a living cell to live and grow. That differentiates them significantly from bacteria. And as we talk about disinfection today, often the disinfection that you hear of is for bacteria. Viruses are quite different in this regard. They're often compared to photocopiers because they can make lots of copies of themselves once they're inside a host. So with that, let's move into this presentation. I'm going to start here with a cautionary tale. These are examples on your screen of risks of using germicidal ultraviolet equipment inappropriately. And people obviously suffer from that, and they're hospitalized in some cases, but it's primarily short-term. But that doesn't minimize the pain involved, because these can be really painful consequences, particularly the burns to the eye. We have a slide here on the history of UV, and that obviously that's sounds pretty dry, but on the bottom of the slide you'll see a link to the National Institute of Health website that gives you a 26-page history of germicidal irradiation, and it's very well written. So if you want it, it's downloadable free as a PDF from that website. And in that, you'll find that it was in 1845 that we understood already that microorganisms responded to light. And we've been using GUV, or the germicidal ultraviolet, for air disinfection since 1935. So definitely not a new topic. Often we hear the term ultraviolet light, which is an oxymoron, right? Like computer security, or my favorite, a crash landing. It's one or the other. Light is visible radiation, and with few exceptions, humans don't see it in the UV range. Some babies do, insects certainly do, but humans do not. So light is visible. The term germicidal ultraviolet avoids the negative inference that any association with X-rays and radiation infers. In the 1800s, UV was called chemical rays and heat rays. Those aren't good options either. But when you hear us using germicidal ultraviolet at the IES, it's still irradiation, but that kind of avoids some of the inferences. And GUV is defined for our purposes here as shortwave UVC. Technically, the vacuum UV falls in the UVC range, but it's not used for disinfection. Femtosecond lasers, yes, but not disinfection. And the UV ranges come from ISO 21348. At ground level, with the sun at its highest point, at zenith, sunlight is about 44% in the visible range, with about 3% of being UV and the remainder infrared. So there's the heat. That 3% is UVA and UVB, because the UVC has been absorbed by the ozone layer and atmosphere before it reaches us. And most of the sunburns that you get, they occur at the boundary of UVA and UVB. Sunlight does have a GUV effect with about 1 hour's exposure at a UV index of 10, resulting in at least a 3-log kill. And we'll talk about what that means in another slide. But it's very effective. That's a fairly long duration, however, if you're thinking about disinfecting something, but sunlight does have that impact. About 6 weeks ago, the World Health Organization, let me see here, maybe I advanced one too many. Bear with me just a second here. Yeah, there we go. Excuse me for that. So yes, UVC can inactivate the SARS-CoV-2 virus if it's at an effective dose level. And of course, that dosing level is still not entirely clear, as are some of the methods of measurement, which we'll talk about as we move through this. So the World Health Organization, about 6 weeks ago, they revised their statement on how COVID-19 is spread, and they added aerosols, or small respiratory droplets, to the caution that they'd already issued about large respiratory droplets. And what you might want to note on this, too, is that last bullet point. Small particles can remain airborne for hours, which I think is just terrifying. But they just hang in the air. And that's why the aerosol part of this was so important. And that was only just, again, end of October that they updated that. The dominant lamp, there's multiple ways that you can reduce that airborne spread, and they're listed on this slide, but our focus is going to be on the upper air disinfection. We'll talk a little bit about the mechanical ventilation too, and how you can inactivate viruses on surfaces. But the primary focus is upper air GUV, because that can be done with occupants in the space. So the dominant lamp used for GUV is a low pressure mercury source. Medium pressure mercury is used for water disinfection, but the efficiency is significantly lower. It's just the total output is more important in that application, so it's worthwhile for water, but we don't use it for viruses or bacteria. The image that you see here is of an upper air disinfection luminaire, typically used in occupied spaces and mounted at 7 feet or above to restrict direct exposure. So you don't want anything above this that you value, because it will have an impact. If you had hanging plants, for example, and you cared about them, you'd get them out of the way before you turn these units on. But because it's above people's heads and it's not an issue for an occupied space. Now that vaccines are becoming available, the interest in GUV is starting to decline some, but it's going to continue to be a critical tool in some applications like medical treatment. And you'll note the last bullet here that reads, when you're fighting a war, a single weapon is never used. Upper air GUV, for example, it doesn't address surfaces. So for that, ideally the space is, if you want to address surfaces, the space is unoccupied and the surfaces are directly exposed by the source. Induct GUV, and we'll look at that in another slide, that can help too, but only if the air changes per hour are within an acceptable range of about between 6 and 12 air changes per hour. And most of those systems are designed for odor or CO2 removal, and that can be accomplished with just 2 air changes per hour. So Induct has some limited capabilities depending on your existing system or your willingness to pay more money to change that system. To inactivate the virus in a whole room, you need to expose all surfaces directly. Shadows or even dust can shield the virus microbes from disinfection. We talked earlier about how small they are. If anyone is unfortunate enough to have to stay in the space while you're disinfecting surfaces, they need to suit up appropriately. I mean, that's some serious protective and eye protection and protective garments in that space. And those examples that I gave you earlier of accidents were when it was on and people weren't prepared for it. Some of you may have seen a really great concept of a doorway where people walk through and the UVC is supposed to disinfect them as they walk through. And part of the problem is, again, that those microbes can hide. They can be in the folds of clothes. They can be in the folds of your skin. They can be in shadowed areas. You'd have to spin around in the doorway and hang out there for an hour or so, probably, to get everything covered. So it didn't end up being quite as practical as they had hoped. Low pressure mercury sources are primarily what we use, and they peak at 254 nanometers, which is very close to the ideal action spectrum of about 265 nanometers, which gives them a relative efficacy of about 0.85. And if you want to compare that UVC range to UVB, at 313 nanometers on the low end of UVB, that has a relative efficacy of only 0.01. So the exposure duration to inactivate the virus is just typically not practical at all with UVB, and not at all with UVA. The term here is introduced as the 1 log kill, 2 log kill, 3 log kills. It refers to bacteria, but it's used also for viruses, even though you can't kill a virus because it's not alive. You inactivate a virus. But the bacteria you do kill, and a 1 log kill exposure will kill 90% of a bacterial population. A 2 log doubles that intensity, or 99%, and a 3 log kill, which is what you're hoping for, is 99.9% effective. Now, we addressed most of this slide, but note too that with the upper air disinfection luminaires, they are most effective with constantly mixed air movement. But even normal convective currents can work. Just people moving around in the space can be enough if you've got these units turned on overhead. This is an image of a low pressure mercury lamp used in ductwork. And typically you have a viewing window with a glass or plastic filtering the UV, so you can look in to see if the lamps are on. And plastics like polycarbonate does an excellent job of filtering UV, and glass varies on its filtering capabilities, but for the most part, glass or plastic windows are okay if you're using the low pressure mercury. But there are some sources that you can't use a window for. I'll give you an example of those here in the next slide. Pulsed xenon lamps, not nearly as common as low pressure mercury for this application, but available in the marketplace now. They cannot be viewed safely through a window when they're on. So if there's a window in the space, you've got to turn it off. You can't look through it because they will be problematic through the glass or plastic. Now, because UVC does not penetrate surfaces and it can't disinfect soil surfaces, it's considered a supplemental control measure if used at all for surfaces. Like we said, in fighting a war, you don't use just one weapon. So if you're going to try to disinfect masks and instruments, for example, the most common method for this and the recommended method is hydrogen peroxide vapor disinfection. The handheld products that seem very convenient to disinfect cell phones and other small objects, they're probably most effective at providing a false sense of security, but not on disinfection. The durations would have to be so long because the efficacy of most of those sources is pretty low. So the safety of GUV lamps, that depends on how they're installed, how they're used, and how they're maintained. Fortunately, they've been around a long time. We know a lot about them, so we know how to do this. But I would say that knowledge is not universal, and that is where the problem comes in. I have colleagues that send me examples of UVC products that are entering the marketplace now, and the companies have almost no warnings or no warnings at all on these. And one editor of a publication told me that he went back to the company and asked them about safety concerns, and they said they thought there was something posted on the website. So this is definitely a problem, because even UVC overexposure can cause short-term injuries, especially to the eyes, because the eyes don't have an outer covering like our skin that could absorb the UVC. And that, from what I understand, can be very painful. These next two slides address safety rules for surface disinfection with specific lamps. And the requirements are different. If you're using a low pressure mercury lamp, for example, an LED or a pulse xenon arc lamp, these are very different requirements. And you can see here in the last bullet point, pulse xenon arc lamps, you're going to use welding or cutting goggles to protect your eyes. And nitrile gloves, a synthetic rubber glove, to do that. So, and tightly woven fabrics. I mean, there's all kinds of cautions involved here. Very useful tool. You just need to know how to use it. Upper air disinfection also being covered here by how it's handled. If you see AHU as an abbreviation, I don't think it's spelled out anywhere, but that's air handling units with the internal UV lamps. Here's a little more on the lamp technologies. Uncoated low pressure mercury lamps like those shown here in the image, they can be very effective. Typically you'll see these, they vary in size. The one you saw in duct was one of the biax type lamps, but here you see variations that look much like the common fluorescent tubes, they're just uncoated. I remember seeing in a mall a robotic bot with a number of 4-foot low pressure mercury GUV tubes standing vertically on a bot, like a big Roomba vacuum cleaner, going through the mall to disinfect surfaces. But you just wouldn't be anywhere near it unless you were suited up for it. LEDs, however, they have very low efficacy, and there's some question as if they'll ever be able to compete with the mercury sources. Common uses of UV LEDs are in the 395 to 365 nanometer range for curing, in dentistry, but they can be produced even in the far UV range, 207 to 222 nanometers, but the efficacy is extremely low, which means the exposure duration times become problematic. We're also seeing krypton chlorine excimer lamps moving into the marketplace, and they're very promising too, because they can also produce those specific wavelengths in the far UV region that have lower risks to skin and eyes. But there's still not a lot of actual in-field experience to draw on here when it comes to those sources. The LEDs being very new in this field, and again, low efficacy is their big problem. Here you see a meter that's used for measuring UV. Those meters should be calibrated annually, and what often happens with healthcare facilities is they will hire a maintenance contractor who has these meters, and then that contractor would keep two, one in reserve and one for reference, to compare them throughout the year before they send the one in. Note here too that UV does degrade paint. It yellows plastics. It can destroy air filters depending what those filters are made out of. And as I mentioned earlier, it'll kill any plants in that space. They don't do well with that. Here's some cost estimates for installed GUV product and estimates for the annual recurring costs. And these are just here for your reference. Obviously, it's going to vary by region and product, but it's a good reference tool. Economy of scale lowers the per piece price costs considerably, but no matter how you look at it, it's not an inexpensive solution, but it can be very effective. And what you'll see here are some examples of what's available to you on the IES.org website. We have GUV resources, including a 1-hour and a 4-hour webinar, video, and an excellent 26-page report with FAQs organized by topic for quick reference. And these are free whether you're an IES member or not. We didn't try to make any revenue on these. We just made them available to everybody because at this point in our lives, it's important to everybody. The IES right now has 4 more GUV documents in draft form. They still need to go through the ANSI public review process, but I've got a description of each of them here so you can anticipate these. 2 of them relate to measurements, and one of those is for LEDs and the other for mercury sources. So a lot of new information being generated here to clarify the use of GUV as we continue to move forward. And Cameron Miller is chairing both of the measurement committees, or the measurement documents organized by those committees. And he's from the National Institute of Health. So that, other than the disclaimer, we'll close with a disclaimer. That leaves us an opportunity for some Q&A. If anybody has any questions about this, I certainly will try to address them. And if I can't, I have access to people that wrote all of these reports and do the webinars, and through ASHRAE, I have contacts as well, so we can get you an answer. So Gabe, do you want to open this up for Q&A?
I do. Thank you, Mark. Yeah, I think we got time for a question or two. Would anybody like to ask Mark a question? You can go ahead and unmute yourself to do that.
Hi, this is Michael Hobson. I have a question.
Go ahead.
You talked a little bit about the uncoated low pressure mercury lamps. Are you, and I wasn't clear exactly, are you suggesting that currently that's the best format for using this type of, for this technology, or were you saying that there's some newer LED technologies that would be better than that? I wasn't sure.
No, Michael, absolutely the time-tested, proven solution right now is the mercury lamp. It's peaking at 254 nanometers, and it's so close to the action spectrum that is ideal, which is at 265, that it's almost perfect for it. And that appears to be coincidental and not by design. The LEDs aren't there yet. We have some hope for them, but they're just not there. The pulse xenon, the chlorine excimer, they appear to be working very well, but there's just not a lot of history to draw on of those being used in the field. So if you want to assure yourself that everything is working as it should and as it has for the last 70 years or so, you're using the low pressure mercury sources.
So thanks, Mark. I have one more question.
Sure.
We're always looking at technologies that can effectively and efficiently clean indoor air. Yeah, I think I saw a picture of some UVs in a air handling unit or in the AHU for HVAC system.
Yeah.
We've always thought that air needs to camp out in that AHU for a certain amount of time so that it's able to get affected by the UV. Is there a standard there that we should be aware of, like the air needs to pause, or we need to have multiple lamps throughout that AHU? Or we've never really been clear on what the effectiveness is of installing those within our HVAC systems.
Yeah, in one of the slides, I actually printed the ASHRAE documents that clarify that. But I think it's a TC9 committee works on those documents, but the document reference information is in one of the slides in this deck, so you can actually look up the ASHRAE document. The biggest issue with those is they can be very effective, but you've got to design that ventilation system between 6 and 12 air changes per hour. And most of our ventilation systems aren't designed for that because they're not designed for disinfection. They're designed to get rid of odor and CO2. So they're swapping the air, 1 or 2 times an hour, certainly not 6 to 12. So that system may have to be redesigned to accommodate it, but they can be quite effective. Once again, they will not have any impact on surfaces, no matter what you do with the air changes per hour. That's just handling the airborne viruses. Anything that lands on surfaces is going to require a direct approach. So does that help?
Thank you very much. Yes.
Welcome.
Mark, I bet we have lots more questions. I want to keep us on pace. We had one more come in through the chat, so maybe you could answer that one through the chat window.
All right.
And I will say that we're going to provide Mark's email address at the end here. And hopefully, Mark, you'd be okay with taking any additional questions that come in. And again, we'll provide the slide deck and recording afterwards to everybody.
Oh, yeah, I'd be glad to. Are the UVC lights that some restaurants are using in their outdoor tents and eating spaces regulated and unsafe? That would be dependent on the product and the installation and how they're being used. So I couldn't say absolutely for that one. I'm sorry. It would be very specific, but if you want to be that specific, get a picture of the thing and send it in, and we'll try to figure it out. Gabe's going to hand out my email address.
Okay, I want to do a quick poll here. I think we're wondering, is this a fad or is this a long-term thing? We've had, some people suggest that the Department of Energy should really do a lot more work in this space and support more R&D. And yeah, so do you see this as something that's short-term, really driven by the pandemic, it's long-term, or it's something, maybe it's overblown and not needed? We'll give a couple minutes for people to answer that. About 10 more seconds. All right, let's go ahead and close that one and quickly share it so people can see how that was answered. Looks like it was close to 50-50. So that's very interesting. So we'll see how that pans out. I know that this will be a topic at the upcoming DOE Solid State Lighting R&D Conference, where we'll be looking for input there as well as to, what should DOE do here to support this or not. So thank you very much for that. And I want to go ahead and move to our next topic and speaker, Felipe Leon, talking about the Integrated Lighting Campaign. Go ahead, Felipe.
Thank you, Gabe. I'll try video and hope this, I don't run into any bandwidth issues, but I appreciate the opportunity to share a little bit about the Integrated Lighting Campaign. So I'm going to give an overview in this slide just to talk about what has happened since we had the last L&E meeting. So the last time we were in transition, we were just wrapping up the Interior Lighting Campaign, which is the precursor to this campaign. And since then, we have launched the Integrated Lighting Campaign with a focus on the integration of lighting with other building and business systems. This could be interior, or exterior. And then advanced uses of lighting and sensors in spaces. So we're looking for things that go beyond the norm. So I'll talk a little bit about that. And what exactly is integration? What are we integrating with, right? So some of the things that we're looking at here in this puzzle piece is that lighting coming together with HVAC, coming together with plug loads. Those definitely have energy stories, right? But then you could have asset tracking systems that could use, for example, Bluetooth beacons in lighting. You could have space utilization through an analysis of your space occupancies. You can understand how your spaces are being used and better optimize their layout, or better understand how that space is being used to some other benefit. So that's integration. They're really now enhancing building performance, and they're going to continue to do so. So we're just in the early stages, right? So why a campaign, right? So what we're doing here is we're trying to provide relevant resources that would inform people that are taking on these projects. We're also trying to promote the use of innovative lighting sensors. We know there's an energy story behind some of these benefits. We know there's other benefits that can really help accelerate the adoption of high efficiency technologies also. So those are some of the benefits that we see here. Also, we want to encourage the integration with other building systems such as HVAC and plug loads. That's definitely a big one for us. And through the campaign, we also want to document and recognize integration and innovation. So what are the benefits of joining a campaign, right? So one of those is, of course, you demonstrate your leadership in tackling these more advanced projects, in putting this technology into your spaces. You can get recognition from the Department of Energy for successful projects and exemplary projects. You also have access to resources such as the Pacific Northwest National Lab resources, as well as other lab resources. We're connected with other labs and can certainly help help you understand some of the technical aspects of this technology if you have questions through our technical assistance, right? So how do you become involved? It's real simple. It's the integrated lighting, it's integratedlightingcampaign.energy.gov. And that, as I'll see on the next slide here, Gabe, is going to be your primary resource for lighting integration from our website. So just a little bit about terminology that you'll see on the website, something we want you to be aware of if you choose to join the site. And the campaign is participants, right? Many of you may be building owners or facility managers or related to the actual end user in some way, right? So we call those participants. So those are the people that are actually incorporating this technology into their projects. With respect to supporters, those are all the others that aren't directly using these systems in their spaces. So this could be a manufacturer, utility, energy efficiency organization, distributors, and others. And then our organizers are listed on our website, and they are really helping guide the efforts of our campaign, and we really are thankful for their support. So some of the resources that you'll see on the campaign website, incentives, right? If you're taking on a project that has integration, what are some of the incentives that are out there that can help you improve your payback? Some of the reports that are out there, right? If you're installing a plug load system, what are some of the things that you might want to use in plug loads to get the maximum benefit out of that controlled receptacle? And then other information such as webinars, videos. So please check those out, and you'll see that there's a lot there. Now, recognition. This is a nice event. We have a yearly event where we provide recognition in a public forum. And the process is now open to submit your projects, right? So I want to make sure that you have that opportunity to take advantage of this and get that recognition from the Department of Energy. And then lastly, just to let you know, the join process, it shouldn't take you more than 5 minutes. We really ask for some basic information, your organization, your name, your contact info, a little bit of background about your buildings, and that's about it, right? And we'll follow up with you, and hopefully if you have any questions, we can answer them either by email or we can certainly set up a follow-up time. And then there's a join button, join section just on the upper right there that you see in red, and that's where you'll have the ability to join as either a participant or a supporter. So recognition categories. So I talked about getting recognition from the Department of Energy, and here are some of the categories that we are covering in the campaign this year. We are looking for advanced use of sensors and controls for lighting. We know that there are still advances in lighting going on, right? So if your project is going beyond the norm of basic occupancy, daylighting, dimming, and scheduling approaches, we want to hear about those, right? The other one is the integrated controls for plug loads and lighting systems. As I said, we're a lighting system now. For example, you have occupancy sensors on there. If those occupancy sensors are connecting to a building system and they're informing those plug loads that there's no occupancy in the space, that leads to energy savings. And we want to hear about those kind of integrations in buildings. And then integrated controls for HVAC and lighting systems. There's innovative approaches to save energy by managing the lighting and HVAC together. Same thing. Use your occupancy sensor, understand this, the occupancy in your space. And when there's nobody there, you could set back your temperature. You could adjust your ventilation in the space, all to gain energy benefits. But we know there's also other ways we can integrate lighting with other systems, right? So we are also interested in those. For example, if you're responding to grid signals to save energy, if you have photovoltaics that are now integrating with the lighting and automated shades that are adjusting based on that lighting sensor, asset tracking, security systems. There are so many systems that are now able to use that occupancy sensor or other sensors that could be incorporated through lighting. And Mike will probably talk a little bit more about other sensors that you might incorporate into lighting. Next slide. A little bit about the recognition process timeline will be on this slide there for you. So what do we ask for recognition? The process, again, we're trying to make it as simple for you to join, as simple for you to submit your project for recognition. Here's an example of what you will see when you're submitting your project for recognition. We're going to ask for a project description, a narrative that tells us, you know, what is it that your system does that makes it unique, right? What are the novel capabilities that, and what do they provide? And what are some of the outcomes that you've seen? And then if there were any measured benefits, we'd love to hear about those. If you know you're getting 10, 20, 30% savings in your HVAC because of it, please put that where it says measure perceived benefits. If it's a perceived benefit such as, hey, we get feedback from employees that say, you know, they like the lighting, they feel that the light level is now at a point that they like, they like the ability to customize it to their level, things like that, right? So those are perceived benefits that maybe we don't quantify, but they really make people's environment more comfortable. So those are the things that we're trying to catch there. Next slide, please. So shown here are some projects where lighting integration has occurred, and research has been conducted by the Department of Energy. These projects are in several building sectors, space types, and they range in size. But I think we see a similar story when we look at the lighting benefits here, right? We're looking at savings here, lighting savings, anywhere from 57% to 76%, right? So we know that LEDs and higher efficiency technologies in lighting today can lead to a significant amount of energy savings. And these systems, of course, also have the advances of occupancy sensors and daylighting sensors, so they're able to dim and turn off, leading to additional energy savings. So that's certainly encouraged. But then where these projects go beyond the norm here is that lighting sensor is now informing a plug load system, and they're informing HVAC systems. So here you can see that in 2 of these projects, some plugs were controlled, and you can see the plug savings here from 38% to 71%, and due to project details, which will come along with the report. Unfortunately, 2 of the projects, we did not have inconclusive data to make a claim there regarding energy savings. So with respect to HVAC savings, once again, you're seeing some very encouraging numbers here in terms of anywhere from 26% to 82% energy savings in these spaces. So there are a lot of opportunities to save energy, really help pay back for the technology and the integration of these systems. And the reports on these will be published in the coming months, so you'll be able to see all the details of those. And then I just want to remind you, joining the LLC is one sure way that you'll receive updates regarding the availability of these reports. So I encourage you to sign up, and I look forward to hearing from all of you. Some of you may have already integrated your lighting systems. So I really would like to hear, as we go into the poll question, your projects, what your technologies are in your buildings, and hopefully we can have a conversation about that afterwards. Thank you, Gabe.
Thanks, Felipe. I know when I saw these numbers, I was kind of shocked, blown away. 20, 30, 70, 80% savings on your HVAC, which is just a huge building load by integrating with your lighting. So really looking forward to the reports. Does anybody have, I think we have time for maybe 1 or 2 questions for Felipe, quick ones. Do you have any questions for him?
Yeah, this is Francis. I guess I'm pretty much going to echo what you said, Gabe. I guess I have to wait for the report, but I'm really surprised about your HVAC numbers, and frankly pretty encouraged. I know that in my long career at Lawrence Berkeley Lab, we spent some time bending our pick at that problem, trying to see basically whether we could get any HVACs, and we were never even successful at doing the technical integration, much less actually demonstrating savings. So I'm very curious to see how the methodologies and frankly, I'm quite encouraged by your results, because I thought it was a dry well.
Yep, I think you will hear a lot that 30% range. I think some of these numbers, keep in mind that we're in a very odd year, and that there is a situation where some of these buildings might have a lower occupancy, and that might lead to additional savings. So that's something that will be detailed in the reports, so that's made clear that these 70%, 80% numbers may be impacted by COVID, by the situation in that specific building, where occupancy might have been reduced significantly. So those details will be in there, so you can make your own determination whether that building might have been able to come up with a 50%, 30%, or less.
Thanks.
The basic gist, Felipe, right, is that you've got the granular sensors and like every light fixture from your lighting, and you can use that granular sensors to kind of align that with your HVAC zones and set some things back, so it's only running when it's occupied. That's the basic gist. That's how we got these numbers.
That is, so some of these projects have light sensors built into the fixture. So that's something that will be detailed in the report. Michael Meyer has a little bit more details about each of these specific projects, But yes, there could be a mixture of both integrated into the fixture or just space type occupancy sensors. And just regarding how to, we had a nice presentation from Kenny Seaton during our launch event. That video is on our website now, and if you went to the resources, you can actually see the video where Kenny Seaton talks about that, connecting the zones for your lighting and your HVAC. So if you're interested in seeing how that works out, you're welcome to go take a look at the video. It's about 10 minutes, and he's just really a great presenter there about integrating that lighting system in the HVAC system.
Okay. Great. We're running short on time. I want to leave enough time for Michael. So Felipe, I apologize. I'm going to forego your poll, and maybe we could just follow up with attendees afterwards with that question. And
sounds great.
And they can respond that way. Michael, I'm going to go ahead and hand things over to you to talk about the separate but sort of related to the campaign, the IoT challenge.
Thank you, Gabe. You can continue on to the next slide. As we've been mentioning pretty much throughout the presentations, our lighting is getting smarter and we're doing more things with it. And one of the new things, which is a value add to your systems, is this lighting and Internet of Things. The idea is your light fixtures in every room above you has power and is a place to put a sensor. Using those sensors, you can do a lot more now. One basic thing is integrating it with such as your mechanical system or other building systems. But you can also use the sensors for helping with contact tracing now that we live in a COVID world, workplace analytics, and health and well-being. So this is really where the future is going with lighting and using it to do and deliver other services. But we need to get there, and that's what the challenge is all about, is how we're going to get there. Next slide. So the large problem is that most lighting today is installed. Tragically, not enough involves lighting controls. Usually the comment is that they're expensive and there's barriers to do it. The other challenge is that you may not know what your building's going to be like, and you might want to add it later, but you don't have that ability. And so there's a lack of standardization and communication and interoperability with those. So the idea is the challenge is really trying to reach out to manufacturers and move into a standardized world for controls, which is where we're going. Next slide, please. This slide really kind of sums it up, especially if you're an older person like me and you remember the first early days of cell phones. So on the image of the left, you'll see a bunch of different types of sensors. These are real products from real manufacturers. They come in many shapes and sizes. They have different types of connections. And the challenge there is each fixture manufacturer has to figure out what size sensor you have to do with. That makes your contracting process more expensive because you have to really commit to a manufacturer earlier on in the process. It also is with each connection, each sensor type, you may have a slightly different connector. And some of the products we're using today are not really smart, meaning they're really analog, which is pretty much what we all remember the first early days of cell phones. But since cell phones have moved into the more digital one that we all use and see the secondary and tertiary benefits from that. And that's what we're trying to do here by a standardization on the right. So there are other efforts underway, and we are definitely supporting those. And the idea is we're going to standardize on a set of shapes and sizes and electrical connection. And this is going to make getting controls on your projects easier. Next slide, please. This challenge really focuses on what goes on inside the luminaire. It would be great if we could get the whole world to work under one type of digital ecosystem, but we know all the challenges with that. And so we have to take very small steps. And that's what this is. It's starting really inside the luminaire. What it does is it focuses on what is happening in the power supply of the LED device. And the idea here is that you can, by putting a smart digital driver in, you can query it for information, like true energy data or diagnostics information. If your fixture is having a problem, you can actually dial into it and kind of like your car dashboard and get information out. Up until recently, lighting fixtures have been a bit of a black box. If there's a problem, you don't really know why or what the point of failure could be. This is going to help you get there. But again, it only standardizes on communication and other protocols within the luminaire. This still allows great flexibility outside the luminaire if your building has its own communication protocol, such as Zigbee, Bluetooth, Thread, 6LoWPAN, or many other types of things. You can still use that because of the partnerships of those communication protocols with this. So again, start small and digitize and standardize on what's going on inside the luminaire. Next slide, please. So the final slide here is just what are the benefits? Well, as an end user, by converting to a challenge compliant fixture with controls, you're probably looking at 70% more or savings just in energy lighting, lighting energy. You can also, now that you have a smart sensor, you can also combine that with other building systems for more savings and more value add. Again, it's simpler and more cost effective. And again, it's really reducing the risk of what you might do in the future. If a new sensor technology comes out in 1 or 2 years, by standardizing on it, you can replace it and upgrade easier. What to know for building owners. The schedule is shown there over on the right. We're going to kick off in January. We expect to see products in June, and we're hope to recognize people roughly a year from now or a little later. We are still seeking end users to help indicate demand interest. The idea here is manufacturers are interested, but it's always helpful for them to know where to put marketing and development dollars if we can show that manufacturers, this organization is very interested in possibly one of these products being on the market. It is a no commitment type of thing. We're just kind of asking for names so we can tell manufacturers this organization or this state agency is very involved and very interested in possibly specifying this product in the future. And again, if after we have a product, we would love to possibly do an on-site evaluation to see how it's going for you and your organization. I'll turn it back to you, Gabe.
All right, thanks, Michael. So I think we have time for a question or two for Michael. I guess maybe I'll ask one. And you know, standardization has been elusive in the lighting industry, and we've just seen so many proprietary products, which causes all kinds of issues for people. What support do we have so far for this program? Is industry on board?
Various entities are. We have reached out to both utilities and energy efficiency organizations. I would say we have about 6 or 7 major groups that are involved there. They see the value in the energy reporting, the diagnostics. We've also reached out to a number of end users, and we have, I think, 10 to 12 different end users that are ranging in size from small to very large national organizations that are also supporting it. They see the value in yes, in getting the standardization. And the design community is also coming around on it because they see standardization as helping them. One of the biggest challenges we hear about lighting controls is having to learn new technologies with each vendor product and the proprietariness of it limiting some of the abilities in the designs.
Mm-hmm. And I already sort of knew the answer, but I think we've got 8 or 10 manufacturers that have already expressed interest saying we want to participate, we'll bring this solution to market. So we're optimistic here about this one, pretty excited about it, and really taking a big step forward. Any questions for Michael? Okay. Well, Michael's email address is right on the screen there. And we've also got an email address for this program. So any questions that come up, please feel free to reach out directly. And we did have a poll. I think I'm going to skip that. See how we're doing here. 5 minutes. Actually, why don't we go ahead and launch this one? Sergey, if you want to launch this. I think we're interested in which of these IoT use cases are of greatest interest to you. Which ones might have the most value? These are all things that you can implement really by installing advanced sensors on your lighting system and the data that's provided by those sensors. Feel free to choose up to 3, I think is what we said here. Give that about 10 more seconds. Okay, let's go ahead and close that one and share it. Interesting. We've asked this one before and got a little bit of different answers, but we've got energy and maintenance optimization really high on this list, which is great, especially for the Department of Energy. System integration, very high. That's great for Felipe. And what else here? Did we have the COVID stuff on here? Yeah, proximity sensing, contact tracing. Okay, so that one's just 2. Okay, thanks everybody. Very informative information for us. And stop sharing those. And so I think we've got 3 minutes left, and we usually try and open things up for any general questions, thoughts, or comments, topics of interest that we might be able to support or provide more information on. And I want to keep that open for a minute. I know some people are going to have to drop off, so before I kind of open that discussions up, I just want to mention that we'll be sending out the slides and recorded webinar link to all the attendees. And we've really appreciated your attendance here. Our next meeting will be in spring of 2021. And I think we're looking for more, for anyone that might be interested in joining this group, to go ahead and reach out to us, and we'd be happy to put you on. And you can email myself or Felipe or Michael for that. So if you've got to drop off, thanks again for attending here today, and we'll follow up with some additional information.